Unmanned aerial vehicles, or drones, are finding more uses in agriculture. One possibility is determining the elevation changes in rolling fields. Putting the UAV information in a usable format can require considerable computer power and photogrammetry expertise, as Richard Pickett explained during a presentation at the Arkansas Soil and Water Education Conference.
So moving on from the cut field ratios, now we'll get into the elevation analysis side of what all this software and technology can do. So this is a 400-acre pivot field with raw elevation data that's been surfaced. And the software that I use, you can bring this raw elevation, surfaced elevation data into the software and apply different layers on top of it to identify, for example, elevation change off these ridges from the major ridge down to the bottom of the low areas of the field. You can see how much of a drop you have. Then when you go, you can apply a different filter to look at the depressions. So this gives you an idea of where you're holding water in your field to help you with drainage designs. Another filter that you can apply to it is flow direction. So this gives you an idea of how the water flows off of your ridges into your drainage areas and ditches. And then this as well is called the flow paths, which gives you an idea of how the water accumulates into a path-like flow pattern into a ditch and then out of the field. So when you overlay all of these together, you're able to really zoom in and understand how your field drains and where the good and the bad areas are in terms of where you need to put ditches and where you don't, and where they're not needed. So from there, I manually draw in off of those different layers combined where drainage ditches should go and create guidance lines for Trimble or John Deere software to auto track all these lines to where you wouldn't have to eyeball all your ditches in individual fields prior to planting season. The pros and cons of drone elevation data, there's a lot of both. Pros is the amount of coverage area you can do in a day. So between my small and fixed wing drone, I can cover anywhere from 250 to 1,500 acres in a day, or you can look at it by the hour. I can cover 100 to 300 acres an hour. There's potential to cover more, but that takes waivers and some other stuff with the FAA to accomplish that we're working on. However, say collecting 1,500 acres in a day, you're talking a long processing time. So maybe 24, 48 hours to get off that 1,500 acres processed before you can get it back to the customer. But it still enables you to collect more data in good conditions and work on that data, say prior to a rain, where you wouldn't be able to cover that many acres if you were using a ground rig system. Entire field elevation collection. So like we previously shown, it collects data points across the whole field. There is no swath pattern to interpolate. It's multiple, on the average, I do anywhere, depending on what the customer wants, from half a foot per point to 5 to 10 feet per point, depending on how they want to handle how their computer system can handle the amount of data. Another pro for us is being able to survey the ground when it's wet. However, standing water is not able to be collected with drone photogrammetry or LiDAR data. So big, large standing areas of water in the field will give you false readings of elevation height, just like grass will give you false elevation readings of elevation height with both drones and LiDARs. And I'll be showing some examples here in a second. And that's because drones can't penetrate vegetation well, which is one of the major cons, as well as water, like I just previously spoken on. And then another, it's not really a con, but it's a deterrent for most people, is it requires extensive geospatial information system knowledge, as well as photogrammetry knowledge and expertise to make all of this happen.